So today what we're going to do is we're going to show you how to mind map. And this mind map technique, I have been inspired by quite a few people. The first of which was introduced to me through a cognitive enhancement program that I went on called the Love Brain. Check them out. Brilliant. And then from there, I also read up and I did research in this area. I've looked at some articles around mind mapping because I found it a very powerful way to extract information, learn information, process, and also remember information. Today, what I want to do is just focus in on the real processes of how to get the main information from a piece of text, the things that I do to make me better able to understand what I'm reading, and then transpose that onto a mind map. So let's have a look and see how to do this. So we've got three pieces of text, and in this text, what we need to do is figure out what information is a useful idea and which of these are powerful terms. Useful ideas are those which you can easily visualize in your mind's eye, meaning you can picture it, you can easily find some type of image in your mind, you can imagine, you can associate with something that you already know. There's an easy link to that particular word or phrase or idea. And we're going to try and make sure that we circle these words because they are the important ones that we are going to keep on our first main branches. And then the second lot of sub branches are going to be those which are more technical words or words which are difficult to visualize or associate with. Tricky words that you need to remember, like for example a person's name, a date in a history exam for example, or some type of formula if you're doing science, or anything else that you've not really heard of and you're not sure what it means. So that might be a technical term for you, and for that we're going to underline it. So let's have a look at this text then. Taking this from a GCSE textbook, it's a small piece of text and I've referenced it for your benefit. This one is talking about the atomic structure. What does it tell us? What information can we get from it? Now, before you even do this, you should do a little bit of priming. If you're in GCSE level, you might have done something at Key Stage 3, most definitely. So you might already know something about the atom, right? Think about that, visualize that. What are there? Were there any things that you remember? Was there anything in the middle of a atomic structure? Was there some things on the outside? These are some of the thoughts that you should have before you begin. But anyways, let's have a look at this text. So you have now seen, and I'm going to read it from here. I'm going to point my arrow so you can see it. You have now seen how ideas about atoms have developed over time. At GCSE level, you use the model in which a very small nucleus is in the center of every atom. This nucleus contains two types of subatomic particles called protons and neutrons. A third type of subatomic particles orbit the nucleus. These are really tiny particles called electrons. So lots of information here. Well, what do we need to do? Well, the first thing is, the first line is just a little bit of introductory text. Don't really need that information. But the second line is very important here because we've got information about where the protons and neutrons might be, and they are in the nucleus. So in the nucleus, now for me, the nucleus is actually quite an easy word to visualize because I'm thinking about the cell in Key Stage 3, something that controls the cell, the powerhouse of the cell. Anything to do with the nucleus means the middle usually. And it helps me because it says that it's in the center of every atom. Cool. Important information. Do I need to underline that? Probably not actually, because that's a idea, a key idea. So we can also make that in the center as well. I don't know why I wrote it in white or yellow. It doesn't really matter for the time being. This nucleus contains two types of subatomic particles. Oh, wait a minute. That sounds a bit technical to me. So let's underline that. Subatomic particle. And they are called protons and neutrons. Now let's assume that we don't know what these are at GCSE level. So let's underline them because they're now technical words here for us. A third type of subatomic particle orbits the nucleus. Oh, interesting. So orbits. Now I'm thinking about the Earth orbiting around the Sun. The Earth orbiting around the Sun does a circular motion. It's doing something around the Sun. The Sun could be the nucleus. The Earth could be the electrons in this case. So they're really, really tiny and they're called electron. Now tiny, that I can circle because that is really something that I can visualize in my mind. Particles, I've seen that before. I've seen them in particle diagrams, so I know what that is. And electrons, I might not know what that is, so I might underline that one as well. So let's move on to the next line. Protons have a positive charge, neutrons have no charge. That is why they are neutral. So interesting here. So let's just use different colors for protons and neutrons here. So let's just use blue for protons. So we've got these things again, and they have a positive charge. Now positive charge, I've got a nice circular idea of what that looks like. Neutrons, I'm going to use the color green because I'm thinking of neutral neutrons. So no charge, and I'm going to circle the word no charge here because that again means something that I can actually visualize. Zero charge, yeah, that's pretty easy to remember and pretty easy to visualize. And I know that it's associated to the word neutral, so I might want to help me remember that by writing down the underlining it or circling it in my case, and then moving on. So the nucleus itself has an overall positive charge. So here we're just understanding here that in the nucleus we don't have a neutral charge, we have an overall positive charge. So this is really important. Okay, and I'm just going to again associate that to the nucleus. All right, sometimes what you might want to do is you might want to write on top of it as well. So if you know you've written something quite interesting there and that's quite an important connection, okay, you can just write over here positive, so you know that the nucleus is positive. You can do that. It's your notes. It's totally 100% personal to you. Moving on, the electrons orbiting the nucleus, which are those things that are going around and around the nucleus, are negatively charged. So here we have to understand that we've got something that's negatively charged, and I might use a different color. Let's just use yellow for the time being. They're negatively charged. The relative charge on a proton is +1, which kind of links to this information over here as well. And the relative charge of an electron is -1. So let's put that and circle that. Notice that I'm using the same colors when I'm trying to process this information because I want to make sure that when I then try and put this in a mind map to be able to really quickly access the information and put the like information together. Okay, let's move on then. The mass of an atom is concentrated in its nucleus. So again, I know what mass is, so that I'm thinking about stuff that things are made from, and that is matter, and that is similar to weight but not the same thing. Okay, it's measured in grams, you know, and atoms have a mass and most of it is concentrated in the nucleus. Now concentrated is a word that is quite technical, so I'm going to underline that. And the nucleus, again, we know mass is kept, basically. That's fine. Okay, moving on, I might think of, in my head at this point, because I'm visualizing and I'm processing the information, I might think, or I might visualize the inside of a nucleus being loaded with bricks or loaded with something heavy, because I know that most of it is concentrated in the middle. That's something that I should be visualizing or thinking about. The more you practice, the more you will get better at this. A proton and a neutron each have the same mass. Okay, that means that we know now that the proton and neutrons are the same. Okay, so let's put this and let's write that down. So proton, neutrons have the same mass, and that's really important information again. The electrons are so light that their mass can be ignored when working out the relative mass of atoms. They are so light, that is very important. And I'm thinking of like feathers, because feathers are quite light, aren't they? That's my visual that I'm thinking about. And so again, we're talking about mass of an electron this time, which is so tiny that it's 1 over 2,000. Now, some of you that are good at maths will understand that that's 2,000 times less weighty compared to the proton or the neutron. And that's what this little sentence in the bracket means. So instead of writing this out again, just underneath, I might write 2,000 times less than P and N, roughly. Okay, so the last sentence now talks about a little bit of a idea of protons and electrons being the same charge. So what does it say? It says, because every atom contains equal numbers of protons and electrons. So that again is an easy visual for me. Equal numbers of protons and electrons. The positive and negative charges cancel out. Interesting. So they cancel out. And you think of a seesaw, you might think that you have a seesaw here, for example, and the positive cancels out with a negative. The positive being the protons and the electrons being negative. So this is just a little doodle that I'm doing in my, maybe my book or in my own notes. But that is important because when I visualize that and see that next time, I know that I'm talking about the protons and electrons being of equal and opposite charges, so they cancel each other out. So what does it say over here? It says the overall charge of an atom is therefore going to be neutral, right? It doesn't have an overall charge. So hence we can say over here, again, no overall charge. An easy idea to think. Now, some of you might find that technical, so I can also do this. I can write that as an underline. Yeah, depending on if that's technical for me or not. And then this one gives an example looking at the periodic table. So the carbon atom, which is neutral, it has 6 protons and 6 electrons. So that means that carbon, okay, has a elemental mass of 12 and 6. It has 6 protons and 6 electrons. And because they are the same number of positive and negative charges, if we go back to our little seesaw here, they both cancel out. And that is what we mean here. And this is what this text is telling us. And there we have it. We've processed all that information. Right, in the next video, I will show you how then to transpose that into a mind map.